0.6, so you have 0.8 for the spaceship, and then 0.16 for the projectile, so you get 9.6, but it doesn't, you know, how is it, where do you lose it? Is it from the projectile that you lose the energy? Is it from, you know, both the projectile and the base, the rocket ship have to balance off an energy? I mean, there's a whole series of questions you can ask about this. Set it up like this because, one, you know, it curtails the speed, the addition of the speed of objects to c, and you lose energy every time you apply it, right? So that's not a very good situation. So, right, there's no good scientific explanation for any of this, how you lose energy, how you have to transfer energy, what happens to that energy. Why would you build spaceships or something if you're curtailed by the speed of light? There'd be absolutely no point to it whatsoever. So this in and of itself has a major problem to it, right? If you do nothing but the math, I mean, you get a solution. If you want to think a little bit more about it, then you realize it doesn't work because you're just, you know, by magic, you're losing energy and nobody knows where it goes, how it goes, can you get it back? There's no one, you know, nobody thinks beyond that. So I would say this is sort of like a bad situation, right? Something to think about. All right. If you haven't seen it already, one of the first videos I put up was titled Breaking the Light Barrier, Adding Velocities Beyond the Speed of Light. And so this sort of dovetails with that, because in that video I just said, yes, it is possible to add the speed of light with the motion of the source of the object, right? So they don't like that, but nevertheless, I think nevertheless it's true, right? And this is just a continuation of it, that the velocity addition equation, yeah, it has nothing to do with reality. It has nothing to do with reality whatsoever. So let us go on to something else here. Well, you know, one thing that this leads to, the velocity addition equation, is that it is mathematical inconsistencies. In other words, if you take the Galilean transformation, you just add them together. 0.8 plus 0.7 equals 0.15, right? So as simple as that. You know, 3-year-old could do it. You know, maybe kindergarten, first grade. I mean, they can do it. It's not that hard. What you notice with the velocity addition equation is what we just talked about at 0.7 plus 0.8 equals 0.96. I've never heard of that before. I've never heard where you add 0.7 plus 0.8 and you end up with 0.96. It has nothing to do with reality. It has nothing to do with reality, right? They want to constrain this additive speeds of objects to being less than the speed of light. That way it satisfies Albert Einstein's special theory of relativity. But it's wrong. And so Albert Einstein's special theory of relativity in all its facets is wrong. That's what I showed in Breaking the Light Barrier, adding velocity beyond the speed of light. Okay. So there's some other kooky things about the velocity addition equation. One is, if you let v prime equal 1, like the speed of light, like a light speed of light, and you let vb, the base, be any velocity greater than, equal to, or less than 1, right, then what you get is is for a given energy system, right, VR equals 1 no matter what energy level you get. In other words, if you plugged in, go back to the velocity addition equation, and you plug in V prime equals 1, and any number for the, like the projectile or whatever, you get 1.0 as your the relativistic velocity, no matter what you put in for the energy or the speed of the base. So, I mean, in a sense, any number that you can put in there, the velocity, the relativistic velocity stays the same. So no matter how much energy you put into the system, additive, subtractive, whatever you want, V will always stay 1. That doesn't happen in reality, right? That's another sign something's definitely wrong. And the other thing is that if you let V prime equal 0, and you let VB equal any number, right, less than, greater than 1, then V relativistic velocity will equal the velocity of the base. So if you put in 0 plus 1.8 c divided by 1 plus 0, right, for V prime, that cancels out, and you get the velocity of the projectile. The velocity of the projectile will give you the velocity of the base. Yeah, velocity of the base equals the velocity of the projectile, right? Yes. So it just comes, so you just get 1 again. That doesn't happen either, I mean, it just shows that, what I find interesting about the physics field and the scientific field is that they have no problem with E equals mc squared, energy, Albert Einstein's energy mass equivalency equation, right? E equals mc squared, right? But when I say the speed of light can be added to the motion of its source, so that you end up with, the speed of light plus epsilon, like a small amount over the speed of light, right? They all go crazy. They tell me I'm wrong, even though this is so small and that's so large. They have no problem with c squared, but speed of light plus epsilon, a small amount, they just don't know what to do. Yeah, they do. They just say that I don't know what I'm talking about, but that's not true. So, I mean, it's not that interesting. It's just an occasion that sort of reinforces the same idea that I've sort of been banging away at. It's just that some of these theories that, have taken on sort of this godly structure, like the special theory and the general theory and all these others, simply aren't true. I mean, if you stop and you think about it and you play with it and you move it back and forth and you see how the pieces fit together, you'll come to the same realization that I did. The special theory of relativity is 100% wrong, period. So isn't the general theory of relativity. 100% wrong. I've done a video on that basically too. So anyway, I'm more interested in science than trying to promulgate someone's personal view of whatever. Science comes first. So what does that lead us? Let me take this out. I know this is a little bumpy, but that's the way it is. So here's another situation. I call it a tale of two theories. And the two theories are both the special theory of relativity, right? Yes. And where's the general theory of relativity? Well, you have the GTR. Okay. So can a frame be accelerated? The basic question I had about this was, can a frame be accelerated in the special theory of relativity, and does it work or not? And for the most part, it seemed to be that the they do accelerate aspects of a system within the special theory of relativity. There's different ways you can do it, but I wasn't convinced that it's actually correct. It kind of goes against the whole grain of what the special theory is all about. So, if I can read this here, you have inertial mass. So let me just read this too. And this is something. This is also another paper that I have. It's on one sheet, right? Yes, the special theory of relativity is designated by STR. The general theory of relativity is designated by GTR. The equivalence principle is a basic postulate of general relativity, stating that at any point in space-time, the effects of a gravitational field cannot be experimentally distinguished from those due to an accelerated frame of reference. Right? More simply, we know it as the inertial mass acceleration is equivalent to the gravitational mass gravity. Right? So what do? We have the inertial mass. I'll just read this out. The inertial mass, F equals ma, is a mass parameter giving the inertial resistance to acceleration of a body which is responding to all types of force. So that's what that is. And then we have gravitational mass, right? Gravitational mass is a mass parameter giving the inertial resistance to acceleration of a body when responding to all types, is determined by the strength of a gravitational force experienced by the body when in the gravitational field, right? So here you have the inertial mass, which I just talked about. Here you have the gravitational mass. Here you have the equation for an inertial mass. Here you have the equation for a gravitational mass. And what do you have that binds these two together? Right? You have the equivalence principle. Right? That's sort of holds these, sort of focuses on both of these. So I did a very simple situation where I said, okay, what if we let the special theory of relativity be a function of acceleration? In other words, we're accelerating a frame in the special theory. So it goes on, special theory of relativity is equal to inertial mass because acceleration is equal to inertial mass, right? Okay. Then the special theory of relativity is a function of gravitational mass because inertial mass is also is equal to gravitational mass through the equivalence principle. So now we have the special theory of relativity is equal to a gravitational mass, which is over here. We know that the general theory of relativity is a function of gravitational mass. Therefore, the conclusion is that the special theory of relativity equals the general theory of relativity. I don't think that's what they wanted. And yet, using basic physics ideas, some from Einstein, most from